So this is the schematic of the kick drum circuit. So, I'm trying to build a drum machine here. So, well, some people asked me how to do the schematic for it. So I'm gonna show you here. I'm gonna go through it. So basically, the core of the kick drum is this. It is an op amp. It has a non-inverting and an inverting input. So this is going to be the output. The signal in is going to the non-inverting side. We're going to you need to use a positive and negative 12 volt supply here. Basically what you need for this in the negative feedback pathway of this op amp is a bridged T network. So it basically looks like this. This is a 1 meg resistor that's bridging the T network. And up here you have a pair of capacitors. In this case, they're 15 nanofarad capacitors. And from here, you need a resistor that is essentially going to ground. And this is a T. And what happens is these are basically high-pass filters. Because it's a high-pass filter, it gives you it provides kind of a notch filter. And when put in the negative feedback pathway of an op amp, it inverts, and so it gives you a signal like this, and it resonates at the frequency determined by these values. That frequency is equal to 1 over 2 pi times the square root of, if this is going to be resistor 1, I used 51K here. R1 times R2 times C1 times C2. And so you adjust these values, and if you calculate it all out, it gives you a frequency, in this case, of about 100 hertz. Maybe a little bit less. I don't remember the actual calculation, but you guys can calculate it for yourself. What happens is when you apply an input signal to the non-inverting input of this op amp, what you're going to have is an output that it goes to the capacitor and it starts a sinusoidal pattern, and it goes back and forth until it decays away through the resistor. And so if you put enough of an input voltage in, what happens is you'll get something that looks like this, and it'll decay, and as your output. So when you take this and you put this output into an amplifier, you'll be able to hear it. Now, how do so it'll adjust, and the decay will be according to the values of these resistors and these capacitors. So if you just take a low frequency oscillator like a 555 timer, and just put in a big square wave signal into this, you'll get two different oscillations. You'll get the minute the trigger goes on, rising edge, it will start the process, and then when it goes down, it will trigger it again, so you'll have a double spike. So in order to prevent that, you have to make a very, very short pulse that goes into it. So the way to do that is with basically a gate to trigger converter. So you need a very, very short pulse. So if you have your low frequency oscillator that is doing something like this, you want to convert that into something that looks like this. And so the way to do that is using, basically it's a type of, it's kind of an envelope generator, but not really. So what you do is you basically take another op amp. So I used a TR808, which has 4 op amps on it. TR808. And so prior to it going in, you want it to be a nice low voltage. You don't want too high of a voltage spike, otherwise you'll hear it in the trigger. So you need something that's divided down. I used 100K and 14K. All you need is a small little trigger here. But to actually get the correct short pulse, what you do is you basically take your input waveform from your low frequency oscillator, trigger or gate, and you put it through a high pass filter, and I used here a 47K resistor and a 10 nanofarad capacitor. And what that does is it converts this to something that looks like this. And the width of these pulses is determined by the size of the capacitor and the size of the resistor, the tau, the RC value, right? And so a very small value capacitor and a very small and a decent sized value resistor will give you a spike that looks like this. Then the problem is you have these negative voltages here. These negative voltages you want to get rid of. So to get rid of them, all you have to do is basically take a diode from ground, and that makes these disappear. So that converts this into something that looks like this. And you take that and you put it into another op amp, into the non-inverting side of the op amp. And this basically, you're using this op amp as a comparator. So, and you're comparing it to a reference voltage value. So you don't need a very high reference voltage value. You don't need 12 volts of reference voltage. I mean, this is going to generate 12 volts, but you just want a value that's, you know, that's low enough. So I used this is VCC. This is your resistor to ground, and I used 100K and I used 20K. So with this, you get a voltage, a reference voltage of about 2 volts, and that's all. That's what it needs to be. It's basically to calculate the voltage at a voltage divider. It's basically 20 divided by 100 plus 20. And that will give you, and then you multiply it by your VCC, and that gives you 20 over 120 is about a sixth of 12 volts is 2 volts, okay? And so that's your reference voltage. So every time this little spike passes 2 volts, this op amp or this op amp comparator goes on. It shoots its output towards the positive rail. And it gives you 12 volts basically. And it gives you 12 volts as long as this spike is above the 2-volt reference voltage. So the minute it goes below 2 volts, which is somewhere around here, so as long as it's above this threshold, it will give you a pulse. And so this output looks something like this, which is a very short pulse, and that's exactly what we want for our trigger. So because it's a 12-volt output, we want that 12-volt output to be divided down and to even less than 12 volts because we're going to hear it go on here. So we don't need that. And so that sometimes when this is below, the output of the op amp gives, or not sometimes, but it swings all the way down to the negative side. And we don't want a negative voltage going into here. And so to fix that problem, we just put another diode. And these could be any diodes. I used 1N4148 because I have a gazillion of them. And so I just use them for everything. All right. That on its own will give you your basic kick drum circuit. You just hook it up to any kind of 555 timer, and this output, in order to be able to hear it, you need to send it through some kind of preamp amplification. And for that, I just used an LM386. And it's loud enough without using any gain to make a good kick drum circuit. So that's it. Now, talk about adjustments we can make to the signal. So the first adjustment that you can make is changing the pitch. So instead of this 51K resistor here, what I did was I put a potentiometer, a 100K potentiometer, and then a 4.7K resistor to ground. And what that does is, as this resistance goes up, it will change the frequency of this. So if the resistance value goes up, this frequency will go down. As this resistance value goes down, and you could get it, and I have the 4.7K resistor in series, that way it gives it a hard floor of 4.7K. As it goes down, that is the highest frequency that it could go to. You don't want it to go too high, because the minute it goes too high, it becomes it doesn't sound like a kick drum anymore. It sounds more like a tom drum. And so to avoid that, you put a 4.7K resistor here. You don't want to, and you also don't want it going all the way to 0 ohms. Now, that's your first adjustment, and that is the pitch. I'm gonna write that in here. Pitch. And so that's the adjustable pitch. Next, we're going to talk about how to adjust for decay. So, you can change this changes the decay too. So you don't want, but every time you change the decay, you don't want really a change in the pitch. And so what I figured out is, and this is from the Roland TR808 kick drum circuit. This is the trick that they used, and is basically every time this is going to decay on its own rate based on the RC values here, you can just keep the voltage running through here, or the current running through here, in this oscillatory fashion just a little bit longer by feeding more in. So how do we feed more in? We use another op amp. And the way to do that is, since this is the place where we want stuff fed into, we basically from somewhere over here, we take a 47K resistor, the non-inverting input goes to ground. This is the output. We put the output through a big resistor here, so because we don't want a whole bunch of stuff going in here, we want it to be somewhat limited. And so we made it a 470K. And then in the negative feedback pathway of this, there is a another 47K resistor. Now, if you know anything about op amps, and as I learned over playing around with this stuff, the gain of an op amp in this this inverting configuration is basically this resistor over this resistor. So this gain is 1. If you make the gain more than 1, then this thing is going to keep injecting more. The output is going to keep going up and up and up. And this thing is going to basically give you a sine wave, and it's just going to never decay away. So you want this gain to go down a little bit. You want the maximum of the gain to be 1. And so by putting another resistor, this time it's a potentiometer, and it's a 1 meg potentiometer. And what that does is, the way the resistances work in parallel, it's impossible for this resistance, this total resistance here, to be more than 47K. It could approach it, but it's never going to be more than it. And what happens is, by dialing the potentiometer all the way up, you're increasing the decay, and by dialing it down, you're decreasing the decay to the normal level of decay that it has here. So if you increase this potentiometer, this is the decay. You will get an output that looks kind of like this. It will decay slower over time at the frequency set by this. So that is the other thing that you could adjust. Now, another thing that can be adjusted is the accent pitch. So the accent is that first little spike that you get, the sort of the attack of the signal. When you hear a kick drum, a bass drum, the first thing you hear is the input or the hit of the spike on the initial hit of the bass drum, and then you hear, which is this, and then you hear something, the actual frequency of the drum vibrate as it decays away. And so you want something, a nice kick to it. So the other thing that we could do here is basically also we need a diode here to prevent the negative voltage spike on the trigger. And so you make a small little tiny envelope generator. So an envelope generator is basically when the signal comes in, instead of a trigger pulse, it's gonna, you put it through another RC network basically, and you have a resistor. I'm gonna draw this out first here, and this is a potentiometer. Okay, and so what that does is it, every time a trigger comes in here, the diode prevents the negative side of the voltage from coming in. And what it does, it goes into this is a 220 nanofarad, and this is a 100K pot, and 10K at the bottom here. So you can't go lower than 10K. What happens is the current will run through here, charge the capacitor instantly, and then slowly decay through the resistance, depending upon what you set the resistance to. So the trigger signal will go from looking like this to looking something like this, which is what it normally looks like. And so you have the attack and the decay, or attack and release in this case. That's what in the jargon that they use. Now what you could do here is you can put it through another op amp used as a buffer. An op amp buffer basically op amp buffer basically looks like this, where the signal is going in through the positive, and there's no resistors at all, and it basically copies a voltage. So that is an op amp buffer. But I didn't want to run out of op amps here, so I actually used a transistor as a buffer. And a transistor as a buffer is simply, this goes to VCC. It's an NPN transistor. I used a 2N2222, and that's a buffer. Very simple and easy to use. And then the other little feature, and I got this from Moritz Klein, who basically re-engineered or modified the kick drum circuit on his channel, is you put this through a 100K resistor, and you put it to, I shouldn't have written that in, but somewhere over here, there is another resistor, NPN, same resistor, and that gets attached to another potentiometer and another resistor to ground. And this is this is a 10K resistor, and this is a 2K hard floor resistor. So basically it can't go higher than this resistance. And what that does is this gives you the amount of the envelope that you use, how fast you want this signal to decay, and what that does is it goes into this resistor and it changes the pitch of this for just the accent, just a short period of time that the initial strike of the drum comes in. And this is an adjustable thing. So you can make this as high or as low. You can make it sound like a tom. It's only for a very short pulse. And then it goes on to whatever the rest of the signal is going to be. But if you do it this way alone, what happens is your output is going to be something like this, and then it'll quickly release to the decay phase. And so it sounds kind of funny if it transitions too quickly. So to smooth the transition, you slow it down. And this is from Moritz Klein's channel, which is great. It's a great little trick, and it happens to be present in the Roland TR808 circuit. You put a small capacitor here. This is a 5N6 capacitor. A diode to ground, and a large resistor right here. And you could do this to ground too, but it doesn't work as well. And so what happens is this signal instead of decaying like this, by using this part of the circuit, it will decay kind of more smoothly instead of something like that, which it starts with. And that's it. That's the entire kick drum circuit. You have your gate to trigger. You have your pitch of the accent pitch. I spelled pitch wrong. You have your main pitch. You have your pitch envelope depth, and then controlled by that potentiometer. And the envelope depth is this. It's this envelope that we're talking about, the attack, the fast attack, and the smoother release. And that's it. And this is the decay of the circuit, the refeeding in of the voltage into this. So, and as long as you have a preamplifier, some kind of amplifier, you can use you can use an LM386 when I thought I was going to use another op amp here, or you could use basically the fourth op amp on this, since this I've only used in this 1, 2, 3 op amps. You can basically put the output through a fourth op amp through a resistor, and you can make this a 10K resistor, and in the negative, in the positive, and in the negative, you put in a much larger resistor, like a 470K, and this gives you 47 times amplification, or 48 times if you actually do the math on the non-inverting input. And so when you have a signal that comes out in the millivolt range, this will make it come out in the volt range, which you'll actually hear on a speaker, and you put it out to a speaker, any kind of speaker jack. So I have this going to an old acoustic guitar amp that I'm using as the output, and it sounds great, as you can hear from my other videos. But that's it. That is the entire kick drum circuit. Make sure you use your the positive and negative, positive 12 volts, negative 12 volts as your op amp power supplies, to give yourself more wiggle room. All right, well, let me know if you guys have any questions. Thanks for watching.